This is Sharif Islam from Fair Digital Objects Forum. This short Fair Digital Object video story addresses questions about whether we need FDOs given major trends in the domain of research data and related problems in data science. Let's start with a pre-remark. The difference between the vertical and the horizontal solutions. Technical systems are deployed to support end users. However, the adoption of technology layers is often not trivial due to the complexity of the system. Users do not need to understand how an internal combustion engine works if they want to drive a car. Similarly, people using smartphones or laptops do not need to know the internal complexities of different components, for instance, the TCP/IP protocol that acts as a common integrator. Users are simply interested in the functionality and the usability of the system, the vertical layer. This also holds true for researchers as users of different systems and applications, such as data analysis or writing tools. Only a few working at the cutting edge of technological experimentation might be interested in the inner workings, which is the horizontal layer. As George Strawn puts it in a short statement, researchers are not interested in standards, only funders are, since agreements on common integrators save a lot of money. According to estimates of PricewaterhouseCoopers, Europe wastes about 10 billion euro per year due to non-fair data in research sector. This needs to be addressed urgently. And researchers will not solve this problem. They will wait for the developer community or the market to create new tools that will incorporate new standards, such as FDO, to improve the data-related issues. Let's now describe some trends that will influence data science in the coming decades and result in fundamental changes in how we look at data. The total volume of data is increasing along with the inherent complexity. Here are two examples. First, in biodiversity research, one estimate predicts 3 billion digital objects representing the physical specimen and samples curated in many institutions around the world, and several trillions of complex relations to different data types associated with these objects. Specialized institutions manage these objects with their own workflow and domain-specific data standards. All these are part of our digital memory that needs to be maintained, curated, and preserved. The interested research community needs easy access to these digital objects with the help of a common layer. The second example, we're expecting 50 billion or more Internet of Things devices producing heterogeneous data with specific contextual properties. Researchers will want to use these digital objects as well. Currently, the number of data silos using different technologies and horizontal solutions on all layers, such as data organization, structure, and semantics, is increasing at an alarming rate. Along with the silos, we have brilliant experts around the globe who all are trying to optimize functionalities, which is of direct interest to the researchers. According to Wittenberg and Strawn, we are still in a creolization phase where heterogeneity and fragmentation are increasing. There's no doubt that leading researchers will want to make use of all the richness hidden in the huge data space. Currently, with some exceptions, most researchers work within domain-driven data spaces and encounter challenges in cross-domain collaborations. This will need to change. For instance, initiatives driven by the Sustainable Development Goals of the UN require cross-disciplinary initiatives. The traditional way of exchanging research results by papers will be amended by reusing all relevant assets created by researchers. This is especially true for data. Open science by design will be the leading metaphor in the coming decades, but it requires to converge on standards and thus reduce heterogeneity. So the pressure towards convergence is therefore increasing. The question is then, in what layer can we agree to converge? George Strawn talks about the transition to the internet decades ago as one virtual computer and claims that we now need the next transition to the one virtual data set. We need a few fundamental agreements to achieve this. The FAIR principles, as they evolved in the last decade, were an excellent start, but more is required. The core of the internet was the agreement on datagrams, which are small self-standing packets that can travel through a network of routing devices. We need to ask whether the data domain has a similar fundamental concept which we can use as building blocks for the next decades, if not more. And this is where fair digital objects come in. FDO mechanisms are fair and thus machine actionable. This means that when machines find some value in a structured format, they know what to do. The FDOs are at the highest abstraction level. For data management purposes, it does not matter what the structure and semantics of the bit sequences or payloads are, whether they are videos, documents, or images. This abstraction provides simplification. We do not need any more different types of repositories, for example. And by indicating the type of the bit sequence, we can invoke meaningful operations, just as we are used to by MIME types in the browsers. If a video is requested by a browser, a video player can start automatically. FDOs do persisting binding of all information to support fairness, independent of technologies, locations, and time. FDO enables the path towards encapsulation, which means that data owners could restrict the set of programs that can be used to operate on FDO's bit sequences. This is especially true for sensitive data. Thus, FDOs are at the basis to improve trust in our mechanisms, and users just need one global, unique, resolvable, and persistent identifier to get access to all this information. FDOs are stable, self-standing units in this dynamic global data space. Let's now discuss some major aspects to describe the potential impacts of FDOs. The most important consequences of agreeing on a worldwide core standard is of social nature. The many creative minds that are now reinventing basics can now focus on finding new solutions for higher order challenges. This happened, for example, when TCP/IP was accepted. Developers used it as needed. This boosted innovation that occurred on different layers of the internet. It is not possible to predict the future directions of innovation, but we can predict that the huge waste in terms of time and money will be reduced substantially and democratize data-driven research. FDOs will create a basic layer of interoperability which can be implemented across all research disciplines. This simplification through abstraction and the binding of all relevant information immediately reduces the wrangling effort without requesting well-structured repositories to be redesigned. An adapter will be sufficient to integrate the existing repository services, which is of great importance since much money has been invested in building such repositories. The domain of digital data will be subject to continuous changes. New data will be uploaded, old data will disappear, new versions will be generated, new relationships will be added, annotations will be made and changed by different people. Due to bundling of information, it will be possible to organize the huge domain of digital objects flexibly by interested brokers. For example, to facilitate finding useful information. If a researcher is looking for specific information according to a specific profile, it will be easier to find suitable data. This must include information about rights and policies. Let us now return to the question formulated at the beginning. Do we need FDOs for data science? The first answer could be in the negative insofar that if your institution has sufficient funds to pay student assistants and temporary workers that do all the data wrangling work, or if you remain within a well-defined limited data space, you might not need FDOs. This is what many excellent institutions currently do. But from our own experience, we know that there are also many cases where research questions using cross-disciplinary or cross-silo data are not followed up, despite having a large support staff. But if we continue these practices, many will be excluded from data-driven science and innovation will be hampered. When the internet was at its infancy, a certain generation of scientists just had discovered the usefulness of fax machine. And their comment at that time was, we do not need this internet. Of course, at that time, they could not have imagined how deeply it would influence workflows and open new possibilities. We're at a similar point of rupture now. We know that the global interoperable data space supporting open science will evolve, and it will revolutionize workflows. And it will facilitate cross-silo and cross-disciplinary work on data in a way that many can participate for the benefits of society and science. FDOs are simply a candidate to enable this transformation, and there is no doubt that this will take some time. FDO comes with a simple basic core model that evolved many years of discussions in RDA and other venues. Therefore, the term fair digital object is owned by the interested community, not by any company or institute. The FDO specifications must be free of licenses. However, they need institutional backing to prevent others claiming rights on the term FDO and its key component. We therefore see the FDO Forum as the initiative that takes care of FDO specifications and it's organizing the FDO community. Turning to a new standard is costly in terms of funds and time. Therefore, the FDO Forum needs to develop in a manner that researchers can trust its commitment and continuity. Thank you for your attention.